Hi, my name is Eden and I'm a service engineer here at NewTech Group. Today we'll be taking a look at how the Videometer captures an image and how the software can help detect counterfeit. Here's our sample. We're going to place it on the Videometer stage, and with the press of a button, the Videometer sphere will drop down and capture an image of the sample using 20 LED strobes. Now that we have our image, our senior application scientist, Dr. Brady Carter, will explain how to identify our counterfeit.
Thank you, Eden. I'm Brady Carter, and I'm the senior application scientist for NewTech Group, and I provide application support for the Videometer instrument. And now that we have our image generated that Eden walked through and showed you how to do, we can now take this image and do some things with it and take a look and see if we can identify if there are any pills or tablets in this group that don't belong there, that are different from the rest of them. And so there's several different things that we can do with our image. First of all, from a very simple standpoint, we can look at the image under different wavelengths of light. And we can do this as a grayscale, or we can do it under a cold or a hot map. So in changing our view, we're now looking at the image at the different wavelengths. So this initial one is down in the ultraviolet at 365 nanometers, or right around that range. Now if we cycle through here, then we can start to see the image change as we get to different wavelengths. We're now at green, 525 nanometers. There's 570, 590, 630, 645, 660, 700, 780, 850. So, and there's 870, 890. And finally 940 and 970 nanometers up in the near infrared. So we were able to look at the image at those different wavelengths, but we weren't necessarily able to immediately tell whether there were some types that were different than the others just by simply going through those wavelengths. Another thing that we can do to try and look and compare these different tablets is that we can actually highlight areas on several different tablets and do a comparison of their spectra. And so what you'll see here on the screen is the spectral response of each of those tablets. And so what we can see is that when we highlight that same region on these two tablets, the spectra are almost identical, which would indicate that these two tablets are actually the same type of tablet. If we move our circle over to another tablet and in the same area, what we see is that we start to see some differences in the spectra, which would indicate that this particular tablet is different from the other one. What we don't know is which one is the dominant type, or which one is the counterfeit, and we also don't know which. We'd have to go through and do this on a step-by-step process and compare each tablet to be able to ultimately find the ones that don't match. Instead of that, there are more powerful tools that we can even use to take a look at this particular image. So if we take our image back out to its normal view, we can apply a transformation to this image by looking at an image of the pure samples. So here we have tablet 1, and here we have tablet 2. Now, if you look at these three images, so here's our mixed image that has both types in it, and then here's our tablet 1 type, and then here's our tablet 2 type. And what you'll notice is that if you look at all three of these images, there's just no way to figure out if there's tablets in there that are any different, just from a visual standpoint. So we couldn't take or have the capability with the naked eye to be able to differentiate between these two. But with this imaging system, now that I know that I have pure versions of each of the different tablet types, I can teach the system how to recognize and learn to recognize each of these pure tablet types. So I do that through a simple painting process where I I paint one type of tablet one color, and I paint the other tablet a different color, and then I use a transformation analysis to be able to teach the system to learn to recognize each of these two different tablet types and differentiates between them through the use of a color map. So you can see now that it colors tablet 1 type red and it colors tablet 2 type blue, and that it does this through what's called an NCDA analysis, where it makes a comparison on a pixel by pixel basis. Now with the system taught to recognize each of these types, we can apply that transformation again to our mixed sample, and then look what we see. So now we see in reddish color all the ones that match tablet 1 type, and then look at those tablet 2 types. So we're able to immediately find the counterfeits in this group, even though with the naked eye there was no way that we'd be able to ever choose or find those counterfeits. By teaching this system, we can use a 5-second analysis and look at this transformation and know immediately that there are tablets in there that aren't supposed to be there, that are counterfeits. We can do this by simply recognizing the tablet 1 type as well, and not necessarily even having the tablet 2 type if we don't know what that counterfeit's going to look like. As long as we've taught the system what the pure is supposed to look like, then we can use this same transformation to find those counterfeits when they're present in a package of tablets. So that's the power of the imaging system, the Videometer. It's both in the fast analysis that you saw that Eden demonstrated, but then also it's in the power of this software to be able to be taught and then be able to apply what it's been taught to future images, raw images, and be able to use that information to find counterfeits when it wouldn't ever be possible to do so using just the naked eye.